Hello, everyone. Thanks for joining us for ShipIt number 10, Building a Culture of Resiliency at Shopify. ShipIt is our monthly virtual gathering where we bring together engineering Shopify folk to talk about the things they're working on and take questions from you that have decided to join us today. ShipIt is a way for us to connect with you in our digital by design world. My name's Anita Clark. I'm a senior managing editor at Shopify, and I run the engineering blog. Today, we're talking about resiliency culture, what it means and how we build it here at Shopify. My guest is Ryan, and he runs the resiliency team here. And they're a big driving force behind this culture of resiliency that we have here. We're taking your questions, so please use the chat and use the Q&A function, and we can see them and ask questions to Ryan after his short presentation. So thank you for being here, Ryan, and look forward to hear what you have to say.
Great. Thanks, Anita. So hi, everybody. I'm Ryan. I lead the resiliency team here at Shopify. I've been here for about 4.5 years now, started as a Ruby on Rails developer, building our wholesale app, and have slowly throughout my career moved more towards the sort of infrastructure end of things. I was on the flash scale team where we were looking at the problems of flash sales and the traffic they drive and how that stresses their infrastructure, and now to the resiliency team here at Shopify. So one thing I want to say before we get started is some of the stuff I'm going to be talking about here, these are not concepts that Shopify has invented. These are things from the broader fields of resilience engineering and some of the things experts have been working on throughout different forms of engineering, software engineering or safety engineering, systems engineering. What I want to talk about really is how we as a company have taken some of these concepts and how we're working to apply these within our engineering organization, and the products that we build. So to get started, just a level set on some of these words, right? So we're talking about resiliency culture, and some of the copy leading up to this event. We talked about building robust systems. We talked about building reliable systems. I want to talk a little bit about what do those three words mean. So first of all, talking about a robust system. So really what we're talking about here is how well do we handle known failure modes, right? These are the known unknowns. I think this is where most engineering organizations devote their time. We're looking at things like network timeouts, looking at retries. We're also looking at a lot of the efforts around quality of software and quality of systems, unit tests, integration tests, code reviews. So we're trying to build things that don't fall over, right? That can handle known interruptions, can handle known failure states and recover, have some redundancies built in. Now, when we talk about being resilient, really what we're talking about here is how do we handle the unforeseen, the unknown unknowns, or the unknown failure modes, right? So here we're looking at not just building systems that don't fall over, but how do we actually build the capacity for our systems to adapt? And this goes beyond just the code running in production. That's part of it. But when we're talking about a resilient system, that's the code, that's the infrastructure the code runs on, the humans operating all of that, all the way up to the company making decisions on how we prioritize and how we develop and release new features, new services, new products. And finally, I want to talk about the word reliable. Obviously, it's something that everyone strives to be. When we look at being reliable, it's can we be trusted, right? Shopify is a platform for over 1 million merchants. They trust us to run sort of the core functionality of commerce for their businesses. Can they rely on that platform to always be there, to always be able to have buyers come in, have a good experience, add items to their cart, check out, process payments effectively? So for us, what this means is as we start to make decisions around being robust and being resilient, we need to consider how that impacts our merchant needs. And quite often there's trade-offs with every single decision. How do we prioritize those trade-offs to best suit most of our merchants most of the time? These sorts of systems, so building robust systems, building resilient systems, building reliable systems, not something that happens by accident, right? This has to be done very intentionally. And to do that, we need to have a culture where we think about these things sort of from the outset. So we're talking about some of the ways that Shopify has gone about building a culture of resiliency and ensuring that we're thinking about these behaviors and these attributes as we go forward. One big thing for us has always been sort of focusing on resilience as a goal. This takes different shapes, at different organizations, and even at Shopify over time has taken different shapes. For a long time, when we were smaller organizations, it was something we leaned on everyone to do. We just tried to push out best practices. We tried to push out documentation. As we've gotten bigger, we've decided that we need to have an even stronger focus on this as a goal. That's why we created a resiliency team. This is a team of engineers looking at, again, the systems that we have. What are some of the things we've done in the past that we need to codify and push out as we onboard new engineers, start building out new systems? Where are some of the gaps that we've seen, and what are some of the best practices, some of the new emerging knowledge that we can take and figure out how to apply? A lot of that work goes towards building effective habits. In addition to an engineering team, we've defined resiliency as sort of an engineering program. We have a program manager who's looking at some of the things that we identify as a team and how to push that through the rest of the engineering culture here. We also have a resiliency education guild where we've pulled other engineers who are interested in these concepts, and we'll read books, we'll read papers, and we'll think again about what are some of the emerging knowledge, what are some of the ways that the field of resilience engineering or the fields of safety engineering are thinking about these things, and how do we take those, adapt them, and apply them to Shopify in ways that are sustainable and help us go forward. And the biggest thing that all of these are doing between our engineering teams, between our program managers, between this education guild, is looking at how do we just enable this sort of learn and adapt approach. So talking about some of the habits that we built these teams and some of the tools we have to enforce these habits. Some of the forward-looking things we can do when we're building a new system or building a new product right off the bat is have teams think about their resilience matrix. So what we want to do here is make sure teams have an understanding of the platform that they're building on and how that platform affects the expected user experiences. So I've got a fairly simplified example here. You can see down the left-hand side, we are looking at a couple of different dependencies, MySQL, a third party called Shopify, the regional network architecture. Along the top and on the columns, we're looking at the different expected user experiences for this service. That the user can browse, that the user can check out, that the user can be served from a passive region. So we go through this matrix, we can see the different sort of known possible failure states of our dependencies and how those impact the expected user experience. So we want to do this right off the bat to ensure we understand the system, to ensure that we know what some of those known unknowns are, and make sure we have built in some capacity to handle this. So this is very much thinking about robustness at the design stage. This also gives us a visualization where we can see where is the system becoming brittle, right? So if we look at this example here, we can see that a user being able to check out, there's a lot of red in that column, right? There's a lot of, any of our dependencies goes down and that functionality is gone. This comes back to our idea of what is reliable. For most of our merchants, checkout is kind of the most important thing, and something that we at Shopify have decided is the behavior we want to try and prioritize the most throughout our system. Being able to add things to cart, being able to check out is the last thing we want to affect. Once we have our resilience matrix, we can start to look at sort of game day and our game day plan. And this is where we can get a bit deeper in how do we handle those sort of known unknowns? What are the tools? What are the techniques? What are the things we could potentially add that are currently missing? So again, we can see here, based on that matrix, we looked at our different components. So these are the dependencies we're pulling in. We can see the different failure modes of being down or being slow. This is simplified to fit on the slide. As we get into our expected behavior, that's where we can really drill into what are our techniques for handling these things? What's our capacity for robustness, right? So we're right now, this is focused on expected customer behavior. We can talk about what are some monitors and alerts we would expect to fire. Are we expecting a team to be paged in any of these scenarios? What playbook would we follow? What automated tools do we expect to kick in? What redundancies do we expect to take over? What manual tools are available to us that we should be able to manipulate? Once we have some of this, we can see, if we start to see some gaps, these gives us a place where we can start to flesh out some of that additional capacity to be robust before we push something to production. Again, this is very much looking at that idea of the known unknowns. Before we start to get into other areas of resiliency, we need to take care of these first. By running those game days, then we can start to see, what is the actual observed behavior versus the expected behavior. Great to do, before we go to production, but it's something else we want to do on an ongoing basis. So if we run these game days on a continuous basis, we start tracking this behavior, we can start to see where does our mental model drift from the actual running system. Systems change, systems evolve over time. Playbooks become stale, redundancies maybe don't work as well as we thought. Manual tools we have start to change, and then maybe the ways that we interact with those. Also, the feedback loops that are presented to the humans operating the system can change. So again, we want to look at over time, do we still have the same observability that we had when we first deployed? Do the same alerts and monitors still apply? Do they still fire? Are teams still being paged? And can we actually still follow the playbooks, the plans, the processes, and operate the system under those different failure conditions? Doing this on an ongoing basis also helps us start to reveal some of those unknown unknowns, right? As we keep trying to exercise the system, as the system changes, more components, more services, different interactions, we can start to see how those failure modes, again, differ from what we expected. Some of the other ongoing habits that we can build as we deploy these systems and as we operate these systems. Load testing, very similar to game day, but here, instead of looking at different potential failure scenarios and how we react, we're looking at different environment scenarios, right? So not only we're looking primarily at have we any degradations in our capacity, the amount of traffic we can handle, the number of checkouts we can handle, but we can also start crafting different load testing scenarios based on things we start to observe in production in the wild, and look at different types of traffic, different shapes of traffic, different ways that traffic in our system, look for degradations, look for changes in capacity. And also, again, how do we as humans react to some of those environment scenarios? What are the tools that we have to mitigate different types of traffic? Do those tools still work? Do we have the feedback loops? Do we have the observability? And do the humans still understand what those processes are, how to operate those tools? As we start, we do these tests, we start to observe the system in production. We can also start to build out some shared tools for common tasks and needs, right? So load testing is a good example of that. We've built out here at Shopify a tool that we can use not only to generate load, but we've also built an abstraction on top of that that helps teams build load testing experiments so they can actually have continuous load tests that run and look for these regressions. They can create ad hoc experiments as new features are being built and see how those react with different shops and different configurations, different scenarios. Some of the toolkits that we have for robust resilient systems, we use something called Semian. Because again, we've built out an abstraction for our Ruby on Rails apps to do things like circuit breaking, to do things like bulkheading, things that we don't want to have teams figure out from scratch each and every time. This kind of gives us a shared basis and a way that we can kind of help expose how to configure things like a circuit breaker to ensure that we're failing fast when our downstream dependencies are down, or how do we configure bulkheading to make sure we're not overloading a shared resource. Proxy is another tool that we use quite often. So as we start to get in, we have our resiliency matrix, we have our game day scenarios. There's some things when it's purely automated, we can do those as automated tests on a regular basis, along with the unit tests and along with the integration tests. Proxy gives us a way to simulate some of those failure scenarios and ensure that our code still continues to react the way we expect over time. And again, these are things around sort of the quality of the system that we're producing. We have load shedding, and again, another thing we've built as we've seen common needs happen. How do we actually start to shed traffic and to preserve, again, that core commerce path, adding to cart, checking out, payment processing, and how do we use some of these tools to limit the blast radius or the impact of incidents? So even as some of these unknowns appear, how do we ensure that they don't impact the platform as a whole or impact large swaths of merchants? So again, these are tools that we've been able to, through observing, through running these tests, and through observing incidents in the wild, build out some common tooling. Finally, here's some of the tools and processes we have just to be able to have safety in the way we deploy changes to our system. So I think everyone's familiar with the idea of beta flags and feature flags, something that we use extensively at Shopify as we push out new changes. We also do Canary Deploys. We have a system to monitor deployments to production, do very quick, roll back to a known good state should we see something that happened in any of our monitoring or any of our observability tools, and encouraging a culture of developers as we create new features, as we're rolling out new code, actually observing these things in production. So we'll do our unit tests, we'll do integration tests. Good ways for us to understand that we hold up to known scenarios at a given moment in time, but can we observe and test in production and make sure that as we start to see mixes of shop configurations, as we start to see different ways merchants are using our systems, and as we start to see different types of traffic and different patterns in traffic hitting those systems and hitting those features, do we observe the expected changes? So we talked about some of the forward-looking habits we have as we start to plan. We talked about the ongoing habits we have as systems are deployed and running and we're maintaining them. Finally, some of the backward-looking habits we have really revolve around incident analysis. So quite often, incidents are our best opportunity for learning, and especially when we talk about resilience and increasing our capacity to adapt, or increasing our capacity for things to go right. Incident analysis is an invaluable tool. Most organizations, I think we've all heard this idea of doing a blameless retro, right? We don't want to blame anybody. I think one of the problems, something that we're still working through here at Shopify, is going from we're not going to blame you, but still seeing human error as a root cause, to looking at the system as a whole and looking at the multitude of contributing factors that happen when we have an incident. And then understanding that things that look like human error are actually symptoms of deeper systemic problems. Rather than looking for a root cause and things that we can patch, and thinking about this sort of prevent and fix attitude towards incidents, right? How do we see what went wrong? How do we deploy changes and make sure that the exact same failure never happens? Understanding how do we increase our capacity to adapt? So it's looking at during an incident, rather than what was bad, what was wrong, what was difficult, right? Do we have issues with observability in our system? Was there data that we were missing? Were there mitigations that we tried to apply that we couldn't? Was there mismatches in process and mismatches in playbook with the system that was running? We also want to look at some of the near misses. So this is where a lot of valuable behavior or valuable learning can be mined, right? The things where something almost went wrong, right? There was some signal, there was some indicator that things were maybe moving outside of the boundaries of normal, but we didn't have a full-blown incident or a full-blown crisis. Something that my team has been putting our time and effort into. How do we start to see some of these signals emerge from the system? How do we start to investigate them, and how do we start to find, again, common systemic causes? And quite often, like when there are no incidents, everything's going right. It's easy to, relax. It's easy to feel really good about the system. It's hard to tell the difference between a system that works all the time and a system that works most of the time until something explodes and we have an incident or we have a crisis. So it's how do we start to catch some of these emerging unknown unknowns ahead of time, and can we see when we're sort of drifting into a less safe state? So talking about incidents, talking about incident analysis, and talking about how we go from an incident to actually learning and adapting our system and increasing our capacity to adapt going forward. I want to tell a story about an incident that we had at Shopify a few years ago. This was at a time when flash sales were really emerging as a thing that happens on our platform. So for anyone who's unfamiliar, when we talk about flash sales, we're talking about sale events that drive sudden spikes of traffic to a merchant store. In particular, we see this a lot with sneakers and streetwear, where there's limited inventory. There's a lot of buyers clamoring to try and buy that inventory, and a lot of bots and scripts and automated systems trying to bypass our system and buy as much as possible, as fast as possible. So I'm not going to keeping the merchant names to ourselves. We had a merchant who was running one of these flash sale events, and we started to see bigger and bigger events, more and more traffic coming. In this particular case, this merchant had some features enabled on their shop and had some features built into their theme that started to put pressure on Memcached in our infrastructure. This was at a time where we were moving from physical servers in a data center to the cloud. We'd made some changes to how we deploy and how we shard Memcache, which, again, we gone through all the testing. We did our resiliency matrix. We did load tests. We did game days. But we were looking at, again, known traffic patterns that we could test against. We hadn't looked at flash sales driving this kind of automated traffic to a single merchant, especially not, again, with this set of configurations and this set of sort of theme customizations. The net result was that this traffic overloaded Memcache, made it slow. We started to see results or requests queuing within our system now, waiting on a slow Memcache resource. This led to elevated response times across our platform and ultimately impacted multiple merchants on Shopify. We had to actually ask the merchant to take down their sale, put out a notice on social media that they weren't going to be continuing, just to try and remove some of the traffic on our system. If we were looking at this after the fact, with sort of a traditional prevent and fix attitude, our focus would have been on the use of Memcache, the features we were exposing to shops, the types of customizations possible in the theme, and how do we start to address those things. And we did that. I mean, obviously that's something that's readily apparent, but we also looked at what's our capacity to sort of withstand these sorts of events the next time another configuration that we hadn't anticipated happens, or next time another difference in the environment where the system's running and changes in the traffic that starts to hit us comes along. We ended up developing our load shedder. The idea behind our load shedder is when we start to see utilization growing, so a single merchant is using more and more web server capacity because we start to see increased traffic, we start to see slow queries, whatever that might be, we can now start to drop traffic going to that merchant based on priority. So we can prioritize that core commerce flow we talked about, adding items to a cart, checking out, processing payments. We can also start to ensure that the utilization of that one merchant doesn't start to impact the rest of the shop by dropping more and more traffic. So we have sort of a controlled failure scenario now. And also now this is a signal where our team can jump in, start to see every time this load shedder engages, and doing some investigations onto root causes. And going forward, this has helped us sustain, wild flash seller growth on Shopify. Something if we hadn't had this capacity built into the system, we wouldn't have survived the last few years. And it's all started to reveal more and more of these near misses that I was talking about. Times where we've had brief bursts in strange traffic, brief bursts in high traffic that have engaged the load shedder that normally wouldn't have tripped any of our larger monitors, but now we're starting to see some patterns emerge where we can do some investigation and start to understand where can we build additional capacity, both for robustness and resiliency, to ultimately have the reliable platform that our merchants are looking for. So that's my presentation. I hope that was useful for everyone. Looking forward to being able to maybe answer some questions that people have.
Thank you. We have tons of time for questions, folks, so enter them in the chat, use the question function, and we will get to them. So our first question is kind of interesting, and I'm just going to ask it straight out, and here we go. Is the sleep functionality for MySQL related to a checkout queue forming under a site under high traffic? This is very probably insider baseball, so remember to default to secrecy, please.
Yeah, absolutely. And I think we have some articles in our blog post about the checkout throttle and some of the work we've done there. Short answer is no, MySQL sleep is not part of it. What our checkout throttle is looking at, again, capacity of downstream systems, MySQL, Redis, Memcache, everything involved in that kind of the process of creating a checkout, proceeding through a checkout, and writing an order for the merchant. And understanding what our thresholds are and how do we make sure we don't exceed those. That, in fact, this is another story of sort of learn and adapt, right? So Shopify for a long time was serving a lot of small merchants. We weren't seeing sustained high volume checkouts on any one merchant until we started to move a bit further into the flash selling world, and we had some cosmetic companies, high value products, a lot of traffic coming in. We had to think about, we started to see these bursts of traffic and high sustained throughput on our checkout. What can we build to make sure we can actually survive that? So this means that sites will stay up, checkouts will continue to flow, and now we can start to look at the bottlenecks on our end and how do we move the needle on MySQL usage? How do we move the needle on Redis usage? How do we move the needle on Memcache usage and start to increase that capacity?
Awesome. Thank you. Okay, our next question is, what are the roles in our resiliency culture here?
So that's a good question. I talked a little bit about the resiliency team. The role of that team is really to think about what within the system of Shopify, and again, when we're talking about system, not just the code running on the servers, but the developers pushing code, product teams making decisions about timelines and roadmap and functionality. So our team is looking at all of those areas and trying to identify things we've done kind of almost by accident that work, and how do we make those regular parts of our culture, and what are the things that we're missing sort of going forward. This isn't something you can buy off the shelf, but sometimes tools are part of this too. So our team owns some specific pieces of code, some specific pieces of functionality around robust, resilient systems. We have a program manager in charge of resiliency for Shopify engineering. Her job is to help take some of the things that we're identifying, turn these into high-level concepts and push them across multiple teams. So she's looking at some high-level initiatives, projects that have been kicked up on that, and how do we get teams to align roadmaps and priority around high-level resiliency, robustness, whatever that might be that we've identified. And finally, we have our Resiliency Education Guild. This is our sort of community culture within Shopify engineering. This isn't any sort of formal role. Anybody who's interested in topics of resiliency, topics of robustness can join. We're looking at, we do reading groups, we read papers, discussions, looking at how does sort of the industry around resilience engineering change? What are other engineering teams doing? What kind of learning can we take? And then how do we apply those at Shopify? Understanding where our culture is right now, where we think it needs to go, and how do we start to nudge it along the way?
Great, thank you. That's a great breakdown. Our next question is, configuration of tenants can be a huge matrix and almost impossible to cover in game days and load tests. How have you solved for the different configurations in your tests to ensure you're covering enough ground?
That is a really good question. A lot of that comes from incident analysis. It's hard to say that and enunciate sometimes. But just seeing the types of incidents that we've seen and what are the sort of, again, we talked this idea of known unknowns versus unknown unknowns. As we see more of these incidents happen, more of these unknown unknowns happen, we can start to transition things over to the known unknowns. So it's hard to, again, get that matrix of every possible configuration in Shopify, because it's a very, configurable system. Merchants can write their own themes. They can install apps. We can plug in other third-party systems. It's trying to find where are some of the baselines and the ranges and some of those things. We look at, different types of shops. Some have very large catalogs of products. Some have small catalogs. Some do, drive flash sales where we have very spiky traffic. Some do sustained sales. It's trying to find all the different ranges and then having configurations that are representative enough that we then do load testing and see what happens. We can run some game day tests. Quite often too, we're looking at running game days and load tests with new systems and new features. So it's, again, finding what is a selection of those types of merchants who really push the platform and enabling new services and new features on representative test shops, again, seeing where do the interactions break down or where do some of the thresholds for load testing start to get hit. But ultimately, we test in production, right? So we can do all these different things. We can do a game day, we can do load testing and verify the system passes this exact scenario at this exact time. It's about running that code now in production, releasing it to everybody else, and having the observability to kind of see how does the expected behavior in production match the actual behavior in production and adjusting accordingly.
Great, thanks. Our next question, have you had any failures of your failure injection framework leading to uncontrolled self-inflicted outages? So have we self-owned ourselves at some point?
Without revealing too much, it does happen at times, which is actually, it's great to do that in a controlled scenario because we know we can cut those tests off immediately as soon as we start to see spillover. We know when a test is running. We know the team is running those tests, so it's easy to kind of do that correlation to causation and decide to stop a test. But it has happened, and in fact, it has driven advancements in some of those other tools we've talked about. So, for example, our load shedder, which is designed to handle those types of scenarios. There's times where we've run load tests on a test shop, and we've seen some impact leak out past the load shedder, and that's informed new features and sort of new scenarios for the load shedder. So it does happen. I think it's important to understand that it can happen kind of at any time, but generally it's better to have it happen in a controlled test scenario where you can control the traffic, you can control the outage, versus happening in production for the very first time.
This sort of is like a cost of doing business with fallible humans, really, in the end.
Exactly. Yeah, and it's as we discussed, like, when we do an incident analysis, it's very much from a blameless place, right? And it's understanding that all the humans who are coming in and operating our system, building our system, we're all trying to do our very best. No one shows up saying, you know what, today I want to take down Shopify, right? So when we do the analysis looking backwards, it's not on, you shouldn't have run that test, or you shouldn't have run this test at this time. It's trying to understand what led to your decisions. Why did that feel like the correct thing? And what were we missing in the broader system to help you make better, more informed choices?
Great, thanks. Okay, our next question is, I'm curious about how the resilience team works with other teams. Is the resiliency team Is the resiliency team, do they look at the overall performance of all the other teams' code, or in the culture that gets adopted by all dev teams in Shopify? So I guess it's kind of like asking, what is your scope, your team's scope? Mm-hmm. Like, do you get in everyone's code and kind of give it the overview before they go live, or yeah.
Right. That's a good question too, and then I think important you think about this idea of focus and how do you actually name a problem and how do you empower people to solve that kind of a problem. In particular, the way we're structured right now at Shopify is my team is concerned about sort of the core product offering and the tier 1 services that support that. We're a globally distributed team of FSREs. We're around 4 different time zones, which means we're online 24/7. So we're the first responders to kind of any medium to high priority incident that is actually having merchant impact. So if we start to see increases in failure rate across the platform, we see a drop in checkout rate, we see increases or drops in traffic increases, anything like that, our team's responding to those alerts and investigating. We're not concerned about the performance of every single service. We trust that we've hired people who know what they're doing and know how to build fast, performant, reliable systems. What we want to do is understand what kind of tools, what kind of processes we should expose to those teams to make things consistent and make things easy. We want to make sure nobody is trying to go from the ground up understanding, what is the service level objective and how do I measure them and what system do I use. We want to make sure that stuff is kind of a platform level thing that we expose to everybody. And then understanding when we see impacts on merchant-facing impacts. So again, we start to see errors. We start to see things affecting checkout. How do we trace those back? And then when we do our analysis, what do we see holistically as a system that are contributing factors to an incident like this? And what are the things now that within culture, within process, or it might be tools that need to be built to help make it easier to see these things go in the future and make it easier to diagnose and correct going forward. I hope I kind of answered that. I feel like I said a lot of words, so I said anything definitive.
Lots of words are good when they seem to make sense, which those ones did. So Thank you. Our next question is, in the face of management leadership who aren't convinced of the value of resiliency engineering, what are some small, easy wins that you can achieve to demonstrate the value and get a foothold in to improve?
That's a really good question. And fortunately, it's something we don't really have to deal with too much at Shopify. It's something where management has very much bought into the idea that these are important. These are really kind of the product features that engineering owns, is how do we build a reliable, resilient, robust, performant platform that our merchants depend on, and the features are kind of built off of that. But yeah, there's definitely times where it's hard to get a foothold, and a lot of organizations are very focused on building new features, finding product market fit, expanding their total addressable market, those sorts of things. I think that some of the easiest wins you can get, first of all, is just starting to measure, right? What gets measured gets managed. Thinking about things like service level indicators, service level objectives. How do you start to take, the performance you see in the wild and correlate that to, end user impact, whoever your end users are, customers, buyers, whatever that might be, and how do you start to sort of draw a line between the things that need to be addressed, the foundational resiliency, robustness things. It might be, quality practice in engineering organization. It might be, addressing tech debt. But I think you start to draw that line towards like actual numbers that demonstrate impact. Now it's easier to say that oftentimes than it is to do it. Finding numbers that make sense, finding numbers that actually represent real impact. If anyone follows Charity Majors from Honeycomb, she has a great saying, nines don't matter, your users aren't happy. So it's really making sure what you're measuring actually measures direct impact, positive or negative.
Great, thanks. The next question is, do you have a waiting room feature set up somehow to allow the customers in when the system can't allow it?
No, we don't use a waiting room. We have our checkout throttle. What we find that checkout is quite often the highest impact path on our downstream systems. So that's the point of our checkout throttle. That's kind of where we enqueue users, where we have users wait. When we talk about things like the load shedder dropping, traffic coming in, that's when we've already hit kind of a dangerous point. And it's something that's hard to predict. It's not any sort of known level of this much is allowed, this much is too much traffic. It all depends on time of day and merchant configuration, the type of traffic coming in. And then we have other tools we can use. So that load shedder is kind of the first automated thing that kicks on. As we do some investigation, we can try and figure out where are the hot paths. And we have some tools where you can do some very targeted drops. It might be a collection page on merchants created that is putting pressure on Memcache, or it might be a third-party app that's making too many API calls on a hot path. But there's things we can do to start to then target and shut down particular types of traffic, or it might be, bot traffic running through a proxy that we can start to shed some of that to enable actual buyers to the site. But yeah, we haven't gone to just sort of the generic waiting room. But that's we feel that we can probably do better than a site waiting room.
Great, thanks for that answer. We have 22 minutes left, so get your questions in, use the question function in the chat, and let's move on to the next one. How does the resiliency team think about bottom-up versus top-down flow of new resiliency practices? How much are the practices tuned for a given team's habits?
That's a good question. I think a lot of these things end up being driven sort of bottom up. It's the people at the sharp end of the system who are actually making the decisions, who see the impact and can understand where reality starts to diverge from the ideal, right? Whereas top down, a lot of that starts to be very much heavy process driven. Do this, and it doesn't always match what we see in reality and what we see human operators in the system actually have to do to operate it and keep it moving. As far as tuning practices for a given team's habits, we try not to be prescriptive about these sort of things, right? It's about making things easier. What are teams finding difficult when it comes to resiliency or when it comes to building a robust system? How can we make that easier? So again, it might be helping teams understand how to better track and expose SLOs. It might be how do teams monitor regressions and performance over time. It might be giving people toolkits for things like Semian. So instead of trying to understand how to build a circuit breaker from the ground up, instead of how to build bulkheading from the ground up, something that's kind of like packaged and ready to go. But yeah, we need to understand ultimately how teams work. What are they finding difficult? And that helps us inform the sort of the longer term projects that we take on as a team. If we find that, Semian doesn't satisfy everyone's needs, so we make changes or we can build something new. We find out there's something in the platform teams are trying to accomplish that they can't. What then can we do and enable the platform to make those things easier?
Great, thank you. Our next question is, how do you manage the time spent to build more resilient products and deliver more features without that high reliable level? I think, yeah.
I don't think the question's about prioritization.
Yeah, like how do you balance having something that's built resilient versus like product features?
Right. It's an ongoing balancing act, right? There's sort of multiple pressures on the system. One is around, obviously our goal is make commerce better for everyone, which means we're going to be constantly changing the system, adding new features, building new services, adding new products. It's a goal that we will never ultimately hit, right? Everybody is everybody's. We have work ahead of us from now to eternity, which means the system is going to be constantly changing. It's about tracking, I think, again, the impacts on the end user performance, and that I give the charity majors quote of nines don't matter if users aren't happy. How do we understand our merchants' experience? How do we understand buyer experience in the platform? What's impacting that? What's getting in the way? And knowing, as we start to see things trending in a bad direction, and this is where like continuous game days, continuous load testing helps us start to see sort of that long tail regressions when we start to sort of pull the brakes on building new things and push resources back to thinking about sort of fundamental robustness and resilient practices and features that need to be built for the platform to stay reliable and stay resilient. I think I hope I'm answering the question there.
If that isn't the answer you're looking for, please ask the follow-up question in the chat and we'll get to it. Thanks. Our next question is one that I'm kind of interested in myself, to be honest, and I should know this stuff working here. What does our observability stack look like?
It's something it's evolving. Where it's a foundational thing to building a resilient, reliable system. But right now, what we look at is Splunk for things like log aggregation, Datadog for metrics and alerts, and tracing. We're just trying to lean more and more into tracing, using some other tools, and ultimately having traces and spans stored in a queryable data store where we can build some pre-built views and see very quickly traces across the system. Again, as we have new services, more products, we want to see how they interact. But if something pre-built doesn't answer the question that we need, we can query that directly. But as it stands today, most of our teams, when it comes to looking at incidents and debugging an incident, we're looking at the logs in Splunk. We've got a lot of pre-built dashboards, pre-built reports, again, that we use to very quickly start to identify and then use custom queries to zoom down. And relying on metrics and Datadog to give us those monitoring of the infrastructure. We can start to see when does the infrastructure move into unsafe states.
Great, thanks. Our next question is, assuming that you use traffic replay for load testing, what controls do you have in place to ensure that this doesn't result in a pollution of production data, for example, popularity rankings? Entirely segregated data pipelines is the obvious solution, but until you can build those out, or in the cases where you need to run on production, do you use data tagging or something else? That was a long question, and it's also pinned in the chat there for you if you want to read it.
Yeah, no, that's a really good question. We don't use traffic replay, I think, exactly for the reasons said it here. Right? We don't want to throw traffic at merchants' production systems to reproduce incidents that have happened in the past. We don't want to skew any metrics. We don't want to change any rankings. What we do is look at incidents that have happened in the past, look at where that traffic manifested as a problem, and then try to rebuild representative traffic to match that for a test shop that, again, we will build to be representative of a given merchant. So if we know that merchant A had an issue, something with their configuration, something with the type of traffic they were seeing, we'll build a test shop that matches that traffic, has dummy data that matches the size of data they have, so the number of products, number of orders, number of merchants, and then build load testing scenarios based off the traffic patterns that we saw. But it's going to be sort of rebuilt from scratch based on what we've seen in the past. We're not going to just reuse the traffic.
Great, thank you. Okay, our next question is one about culture. So they're curious to know if the culture at Shopify is more move fast, break things, or is it more of a fail-safe type of environment?
I don't think it's fair to say we're one or the other. It's something I've seen it fluctuate kind of back and forth both ways over my time here, and it changes sort of team to team. I think if we were to pick one, it's probably more towards fail-safe. Again, we have over 1 million merchants. They trust their businesses to our platform. For a lot of people, they're trusting their livelihoods to our platform, and that's something that we take very seriously. When we start to talk about the idea of move fast, break things, we embrace prototyping, we embrace experiments, but we will do some of that stuff very quickly. But as soon as we decide something is this is the way we're going, this is how we're going to proceed to production, we move to, I think, a bit more of a fail-safe mode, which is not to say we don't move fast. We deploy to production very frequently here. We believe that deploying frequently is a sign of a healthy development team. But we think about ways we can do that where we're not going to be cavalier and we're not going to be taking unnecessary risks with our merchants and their business.
Great, thanks. Our next question is, for traffic shedding, how does the prioritization of the critical URL paths, carts, checkouts, payments work? Is this part of the web tier software? Is it custom built with that purpose?
Yeah, so it's something we've custom built kind of based off of our knowledge of the traffic hitting our systems. It happens at the Nginx layer, so it's not done in Rails. And it's multiple things. It's not just URLs, but looking at multiple attributes of the traffic. So one of the things we can do is web crawler traffic is something we can discard pretty quickly. Then we start to drill into stuff along critical paths. So some things we know, and because most folks are using our online store built off of Liquid, we know that what the URLs are and how they correspond to different paths. So we can drop things like blog posts before we start to drop page views, before we start to drop anything on the cart path, and then lastly anything on the checkout path. And again, it's something where we're constantly looking at how this behaves in production, how we can start to tweak some of those rules, and we have exceptions for some different large shops where we know that their usage patterns differ from the rest of the platform. But yeah, it's something that's constantly evolving. We're constantly trying to make sure we're doing the best we can to, again, preserve as much real commerce traffic as we can while shedding unnecessary load when we start to see utilization increase and we start to see impact potentially hitting other merchants on the platform.
Oh, great, thank you. This question kind of is more of a customer impact related question. How do we calculate, or do we calculate, the loss of sales when you need to drop traffic on these flash sales spikes? And this person also wants to tell you that they're thankful that you're doing this, and it's a great presentation.
Well, first of all, thanks. I was really hoping that someone finds, if at least one person finds this useful, I think we've done our job. We can look at trying to calculate loss of sales. Generally, when we're dropping traffic, again, we're trying to prioritize checkout traffic as much as possible. But we can look at sort of projected traffic or checkout levels versus actual checkout levels. We can look at things like number of carts created versus checkouts attempted versus checkouts completed. We can look at failures versus success on checkout jobs. So yeah, ultimately, loss of sales is something we look at kind of in any incident, right? If we have anything where there's any sort of end user impact, that's one of the metrics that we consider to help us gauge the severity of the incident. And obviously anything where there is financial loss is going to be taken very seriously, not only in the moment, but in the follow-up afterwards and as we prioritize work to be done.
Great, thank you. We have 10 minutes left, so if you have any questions that you want Ryan to answer, please get them in the chat, and we'll move on to the next one. The next question is, what load testing tools do we use? We've been learning K6, or we've been leaning into K6, sorry, and this is Matt. Kind of curious, what company are you at, Matt? If you drop it in the chat, we can look, I guess. Sorry, you can go now.
Yeah. So again, I think we've got a blog post kind of from our Black Friday series around, I think it was called pummeling the system or pummeling with traffic that talked about some of the tooling, but we have homegrown tools for this actually. We've got a tool we built called Genghis, which is a Lua based. So it's a Go system that uses a Lua interpreter to take Lua scripts and generate traffic in the system. We've looked at some off-the-shelf tools, and we have had a hard time finding something that can generate enough load to actually, put us into typical failure scenarios. So we've had to build something off the shelf, and it's something we've been maintaining. And we've also built some tools on top of that to kind of make it easier for developer teams to use. And again, I think it's covered in the original blog post, but we've got a tool called Chronogram that our platform conditioning team has built to make it easier to define and run experiments, whether it's a one at a time ad hoc or to define them to be run on a continuous basis. And there we can kind of track, success, failure, what did we see, any alerts that went off that we didn't expect, and understand, are we creating failures that we didn't expect? Are we hitting load and creating failures we did expect? And are we seeing any impact outside of our test scenarios that we shouldn't be seeing?
Great. Thank you. We have another question from Matt, who works at One Login. If you hadn't seen it in the chat, Ryan. Thanks for your questions, Matt. Do you buffer real commerce traffic at your edge when underlying resource utilization increases, or do you immediately go to drop off?
That's it. So talking about buffering real commerce traffic, that's really our checkout throttle. Right? So that's kind of seeing when that traffic exceeds our capacity purely for everything around, again, as we mentioned, creating checkouts, processing checkouts, or creating the orders after the fact to the merchants. Yeah, we do buffer that. So we have users wait in a queue. We also have the ability to do some things asynchronously, so we can prioritize, again, the buyer experience of add to cart, checkout, process payment, go on, get a thank you page, and defer some of the expensive things on the merchant side, and again, sort of buffer some of that work. We also have some tools we can use, again, similar to the way we do request shedding. We can do shedding based on MySQL utilization, and same sort of thing where we can look at queries that are for checkout, anything on the checkout path, and make sure that those queries get prioritization over everything else. So as much as possible, we try not to drop any of that stuff. We will buffer where we can. I hope that answers.
Great, thank you. Our next question is, does your centralized resiliency team focus on, does your centralized resiliency team focus and alert more on product feature level signals or the underlying services and systems that make up the products?
At this point, it's largely sort of product feature level signals, right? So again, we're looking at, are we seeing checkout rates drop? Are we seeing anything that affects the traffic rate coming in? Are we seeing error rates increase? We will look at lower level infrastructure signals that correlate, that we've started to see patterns over time. So one example here is we have some signals at the database level that would normally alert our database platform team. They're actually not database issues. It's just where some of these product level things start to manifest. Those will come to my team, and we know how we draw a line from that infrastructure signal to potential merchant impact. We know what do we want to look at? The logs. We know what are the numbers in Datadog we want to look at, and we know what tools we can apply to try and mitigate some of those things. More and more, we're trying to understand what are the infrastructure signals that we should be consuming that are kind of leading indicators that product feature level signals are going to start to go off soon and start to get a little bit ahead of these things. And again, that idea of sort of looking at the near misses, where do we start to see infrastructure signals and any numbers there moving into unsafe territory over and over that maybe haven't resulted in end user incidents, but are an indication that we're getting closer and closer to the edge of our capacity and what we can run at.
Awesome. Okay, we've got 5 minutes left, folks. We'll take a couple extra questions here. Thanks, Ryan, for taking the gauntlet for almost 40 minutes.
This is the part I was actually looking forward to more than getting up here and spouting words. Everyone actually want to hear what do people want to know.
Awesome. Okay, so what is the major problem to build and maintain a resilient culture?
I think that the biggest thing to overcome, and it sounds simple, but it is that mind shift away from prevent and fix to learn and adapt. Right? It feels like we should be aiming for nothing to ever go wrong and have no incidents and have everything running 100% uptime perfectly all the time. And understanding that, we're all building complex systems. Complex systems have emergent behavior. And if we're doing our jobs right, these systems should be always changing, right? We should be building new features. We should be building new services. We should be expanding what we do, which is going to lead to more surprises down the line. So it's really getting people to think about less about how do I stop anything from ever going wrong, but how do I increase my capacity for things to go right? And understanding that we're building complex systems. They're going to run in degraded mode, probably more often than not. How do we handle those degraded modes, and how do we make sure that those don't manifest in impact out to our users? But it takes a shift, and I think it takes a shift primarily in how we look at the incident analysis process, and that's something that we're still working to get better at here at Shopify, getting away from the idea of looking for a root cause. We're engineers. We want to have a root cause. It's nice and it's tidy. We can say I can put a PR to fix that thing, and it'll go away. And if you kind of zoom back and look at the system as sort of the greater organization, the engineering team building things, how we're deploying code, how we're making decisions around prioritization, you start to see multiple contributing factors, none of which on their own would have caused an incident, but taken together lead to some undesirable outcomes.
Great, thank you. Okay, let's do the last question. We've got 3 minutes left.
All right.
So here we go. How do you manage this, and I'm assuming resiliency, on reports on large data which you cannot cache and require high processing time?
So if I'm understanding correctly, how do we have resilient reports, or maybe are we talking about maybe the resiliency of a data pipeline? A lot of it comes down to understanding what are our goals, what are we trying to achieve, and make sure we're trying to achieve something that's actually realistic. And who's using these reports? Why can't they be cached? They have high processing time. What is our window on availability and freshness? It's a hard problem without knowing sort of the exact thing we're talking about, the exact goals we're trying to achieve, and exactly like who needs what when, and what are our real SLOs versus our ideal SLOs, right? Ideally, we all want to have 100% uptime and 0-second latency and all the things that obviously are not going to happen in the real world.
Cool. Actually, we have enough time for one more question.
All right, I'll try and go really fast on this one.
What will be a good way to load test third-party services at the checkout? For example, shipping options, providing. Sorry, there's like typing in front of this. Just looking at the answer. For example, a shipping office options like provider.
Right.
We make sure that those guys they live up to our resiliency standards.
I don't have a definitive answer on this one. It's something we're still trying to figure out, as how do we do this sort of holistically across the platform, not only for the things Shopify provides, but for everything our merchants might be using. The biggest thing we can do is run our load tests in our system, understand what kind of load would go off to a similar third-party service, and then work with our merchants, work with our partners, understand in these scenarios, this is the type of load you would expect, and make sure that those partners are doing equivalent load testing, so then we can have fairly high confidence between the partner, between our merchant, between ourselves, that for a given flash sale scenario or for a given checkout scenario, the option will be able to handle the kind of traffic that we're going to generate.
Great. Thank you so much. We are at time. Ryan, this was awesome. Thank you for, handling all those questions. Thank you, audience, for submitting so many great questions today. It was amazing. There will be a video of this event posted on the engineering blog, and we'll also send you an email where you can get that link. In that email will be a survey. Please fill it out. We want to know what you like, what you don't like, what kind of things you want to see us talk about. And we'll also get you there to, you'll also find out about upcoming events. Speaking of our next ShipIt number 12, I can't believe it's been a year. It will be, actually, no, I think that's ShipIt number 11. Maybe we're not on 12 yet. I can't even remember. My mind is going crazy. But February 27th or February 24th, please come to our next ShipIt, and it'll be about WebAssembly. And it'll be fun because it was a big topic over the holidays. We're hiring 2021 engineers in 2021. Head over to the career page and you can see what open positions are there, and come join us and work with people like Ryan and the other wonderful Shopify folk around. Finally, thank you for spending this hour with us, and I hope you enjoyed it, and we'll see you again soon. Bye.
Thanks, Anita. Bye.
Thank you.